We're going to take a look tonight at just some basics of multimeter usage if you are a vapor. Most of them will have a voltage setting. We'll need that to check batteries. And that will be direct current for batteries, alternating current for outlets or otherwise. Mine switches by pushing a button from direct to alternating. Alternating is the wave, direct current is a straight line over a dotted line. You'll need the omega for ohms or resistance. That one's showing it's set to that by OL for open link. Continuity is kind of nice to have around the house, but not necessary. And the amperes and stuff we only get into if we're playing with being within the line of flow of power, which is a little harder to do. So most of these will be just mostly those two. Now, what I was just showing you is an auto ranging multimeter, which figures out which level of voltage or item that you're trying to measure. The ranging ones require you to set the basic range of the item you're looking at. So if you know that you're looking at something that's 200 volts, you have to set it to that range. If you know that it's less, you have to get it in the middle. So for most of our things, they'll be set to the bottom, and the meters can look differently, but usually you'll want the lowest setting because we're only going to like 4 ohms for an atomizer. We're only going to 4 or 5 volts for a battery. Do not buy the analog versions. Get a digital. They're not that expensive, especially the ranging ones. So let's start out with connecting your leads, and they all come with these black and red wires with metal pointed tips so that you can touch things to measure the electrical properties. All meters have connectors on them. COM is for common, and it is the ground. There will always be your black connection cable into the negative ground or common connection. So let's go ahead and put our black one in there. The one to the left is used for testing amperes. Almost all your tests are going to be done for the one that's marked voltage and ohms or resistance. Let's get started. Let's put it to voltage, and it is set to direct current, and yours may look like the inset picture. Set to V for voltage, not the wave. That would be if you were checking an outlet. So we have it on direct current for batteries. Now all batteries have a negative and positive end, which is in the direction in which the power flows. We're measuring the pressure of that power throwing it through the line. Now, negative, a positive will usually be the nipple end. If there is no nipple, the battery will usually be marked negative or positive. So ground to negative. So you're going to put your black tip to the negative end and your red tip to the positive end or the nipple. 4.2, fresh battery. Now you can turn them around and do it the other way. It'll give you the same reading, 4.2. It's just negative because you've confused it by sending the power flowing in the wrong direction from positive to negative. It's just a little finicky about that. Here's an RCR 123A. Same thing. Black to the negative, red to the positive, 4.2. Also a freshly charged battery. Now let's go ahead and pull one here out of a mod that's been running a little bit. And this one is reading 4 volts. So it's run down from its 4.2. This is a good way to tell if you have used or not used that battery, or it's fresh or it's faulty. The next thing that's really important for a vapor is measuring atomizer resistance, or the ohms. Now, this is a big old light bulb. Principle is the same. The threads are the ground. The center post is the positive. So, following the same principles we used on the battery, we're measuring the amount of resistance that gets applied to the current by the atomizer or light bulb that's flowing through. Black to the threads, red to the positive post. Now, it's reading it. I don't know much about light bulbs, so I don't really know what that means. Shh. It was just a good example. So, same principle, and we'll take a look at a 510 atomizer. Keeping in mind, threads are the black, post is the red. But sure, it's being weird. You can also, just for larks, check the resistance of your hand, meaning that there is current that can flow through the body from one end to the other. Now, last one's kind of useful around the house. Continuity is the speaker, and that's measuring whether a flow can go all the way through. In other words, can power flow from one spot I have the lead on to the other. Now this is great for, say, speaker wires. Say you have speaker wires that aren't working. They look fine on either end, but there may be a disconnect in the middle. When there is a direct connection between point A and point B, it will make that beep sound. So here's some RCR stereo cables. I'm going to grab one in one hand, touching the red lead to it, the other one in my other hand touching the black lead, which is kind of hard to do, and there is a connection between them. It beeped. That's what they use for printed circuit boards.